Okay, so here we have system is what we're interested in, surroundings is the rest of the universe. The way that we look at things, the heat of the system equals the negative heat of the surroundings. Right? There you go. This should be heat of surroundings. Right there should be surroundings. When something gains heat, the other loses heat. You understand this concept. For some reason, this becomes very difficult for people, but you get it. If you have your bank account and you give somebody $10, that's negative $10 for you, for the system. But for the surroundings, that's positive $10 because it's been given to them. And so if you think about thermodynamics, that's what this is. For calorimetry, it's just a flow of heat from one thing to another. It's like an exchange of money. So when something gains heat, the other loses heat, or vice versa. The one thing will undergo an endothermic process. It doesn't have to be a reaction. It's just a process. Think about like an ice cube melting. That's endothermic, but you're not changing it. It's not a reaction. So one thing will undergo an endothermic process, the other will go an exothermic process. So one thing's losing heat, the other one's gaining heat. All right. So we come down here, and this is it. All right. So put on your algebra hat. We have 10 grams of aluminum at 300 degrees Celsius. It's really hot. We have 100 grams of water at 10 degrees Celsius. That's pretty cold. So if we put the aluminum in the water, what's the final temperature? So what is final temperature? What is the final T? So here, aluminum. Notice I put aluminum in red. Our mass is 10 grams. This specific heat, this is something that you look up or you find or I give it to you. There's that. Your final temperature, or delta T, is final minus initial. Your final temperature, we don't know. We're looking for it. Your initial temperature of aluminum is 300 degrees Celsius. So we have all of this information. For water, our mass is 100 grams. We know this. Specific heat for water is 4.184. All right. Temperature final, don't know, but it's going to be the same as aluminum. That gives us our one variable. And our initial temperature is 10 degrees Celsius. So you pick. You get to choose. I'm all about student choice. Pick the system, pick the surroundings. Usually in a situation like this, the surroundings will be the water. The system will be aluminum or whatever metal or whatever we're putting in the water. All right. So the way that we're going to go through this is Q equals M times S times delta T. Here's our system, 10 grams. Here's our S for aluminum, TF minus 300. There you go. Then we move over here. This is your surroundings, your water. Notice the negative. Please, please, please notice the negative. That is going to be important. Our mass is 100, 4.184, TF, we don't know it yet, minus 10. And so we just crush through some algebra. I've tried to go through it real slowly. 10 times 0.921, we get this. Negative 100 times this, we get this. We get our F's, then we can put the S together and the one that doesn't have the variable together. And what we find is that final temperature is 16.2 degrees Celsius. Water heated up a little bit, and the aluminum cooled down like a lot. All right. And that has to do with this specific heat. All right. Water has a very high specific heat. It's not going to heat up and cool down real easily. Aluminum has a very low specific heat. It's going to heat up and cool down pretty darn easily. So calorimetry, just to finish this off, one thing always cools and the other always heats up. That's what we have, which you should understand. And it's based on the law of conservation of energy. And for some reason, this is confusing for people. All it means is that energy is conserved. If something loses heat, something else has to get it. So if you think about like, if you go outside and have a fire in the winter, right? Like, oh, this is great. You're outside, that fire is giving off warmth, okay? But it's losing that energy to the entire planet. Okay, so the entire planet really doesn't heat up very much because of that fire that's taking place, right? Even though it's giving up, like it's very, very hot and losing energy. So this applies to everything, to all processes every single day. The law of conservation of energy. This is like the end all be all. We will go through enthalpy and bond calorimetry in the next video.